All right, so now we're going to move on with lesson 6, and we're going to look at the analysis module within arcpy specifically, and then also later on we're going to examine the Tempfile module, which is part of the standard library. So our objectives here are to examine analysis tools. We're going to look at some feature analysis tools, and then learn about the Tempfile module in Python. The analysis toolbox is a collection of tools that performs some of the most fundamental GIS operations. These can be buffers, data extraction, so your clips and overlays, and it's really important to know how you can use them. And these are really good to see how you can put in different data types and get different outputs out. And we're going to go ahead and explain about them. So let's go ahead and start taking a look right here and from the analysis toolbox. So if we want to take and we need to split center road lines by each district, we can go ahead and do that. And one way that we do it is we can mix our cursor objects. So we have a school district and then we have road lines. And we can go ahead and we can split this information out. And this is done by doing first our standard imports. So we're going to use the OS module, which is going to allow us to join our, our road lines together without having to write them out explicitly. And we can go ahead and then import arcpy and then the env and the da modules explicitly. We're then going to go ahead and set our environmental variable to true, which is going to allow us to overwrite any outputs that our analysis tools are going to do. So this tool can be run multiple times, and the intermediate data that it creates doesn't have to be cleaned up at the end because we can go ahead and override it the next run. We're going to store our results in a list, and then here's the data we're going to cut. So we have a data set. It's a polyline. It contains center lines, and it's a shapefile. And we also have another shapefile that is school districts, which is polygons. So all we need to do is get that geometry in order to do our tool. So we're going to do with da.search cursor, pass in the path to our data set, our districts, and then say shape at, which gives us, this will give us back those arcpy geometries that we've learned about before, and as sRows. We're going to use a simple for loop, and we're going to use enumerate. And what enumerate does is it gives you back two pieces of information. It'll give us back an index number starting at 0, so it'll say that this is the first thing you're getting back from your iterator, and then the row with all our values. We can then go ahead and say our set an out feature class. We're going to use ospath.join, put it to our scratch.geo database, and then we're going to use that enumeration index to set that numerical value here. So we're going to use our f-string syntax, do road underscore, and then squiggly brackets in the variable name. We're then going to get our geometry, which is going to be the first item in our index, our tuple. Then we get back, and then we're going to go ahead and do analysis tools. And here's where we're going to sort of see something different. So we have arcpy.analysis.clip, pass in our county center, our center lines, and then we're going to pass in the geometry. And it's going to use that geometry instead of an actual physical feature class to do our analysis on. So let's go ahead and run that. It'll take some time, and it's going to go through and it's going to clip out each district. It'll store the results, and then we'll just get a list of feature classes back. And we can go ahead and print it out. So some things that we want to point out when we're talking about this is that we're using cursors with the standard tools, and we're also using geometries as our inputs for the tools. And that's really powerful. Not everything has to be a static data set. It can be in memory data sets. It can just be geometries. And that'll allow us to do a lot of different things with analysis as we go through. Okay, so this way, that'll finish up in a minute. Whoops. So that's just the one note we wanted to hit here. So we're just going to exit out of here and take a step back and let our example finish. And we'll go back and look at that in a minute. Now we're going to go ahead, and I want to get out of the slide presentation mode because I think it's a little easier to see when we talk about the Tempfile and everything that's associated with it. The Tempfile module, we can import it by doing import Tempfile. And this is going to give us the ability to create temporary file system objects. And these can be files or directories. And we want to use the temp file to create these files with because we want them to have a unique name, and it helps prevent. In reality, it's a security measure, so it helps us prevent theft of data and helps us build secure file generations. But the other benefit of using Tempfile to do all this is that it does automatic deletion once the process is finished. But before we continue on, I just want to show what we did here is that we saved out to our Scratch Geo database and notice that from the enumeration, we put the index in. So we got 0 to 11. It made 11 clips based on geometry, and all our road line data was separated by our polygon boundary area. Okay, now back to temp files. So with temporary files, what we're going to do here, let's go back into here, is that in order to create this information, we're going to use and create non-persistent files, we're going to use the with syntax a lot because recall that with the with syntax, it does the automatic closing of the files at the end, so it takes care of a lot of that cleanup. So we're going to do with tempfile.temporary file as temp, and this is going to go ahead and create a temporary file, and we're going to go ahead and see that. And then we're also going to see the name for our information. So let's go ahead and print out that information. And we can see that we get back a temporary file, and it's a temporary file wrapper object. And then it also creates a physical file name on disk in our temp folder, your system's temp folder, with just some random letters and numbers. So it's hard for somebody to predict how this information is going to be produced when you create temp files. And it also means that the chances of having multiple applications, if you have them running on the same system, stepping on each other with file names is very, very small, the probability of that. So continuing on with temporary files, when we default and create a temporary file, it opens up this file in a write mode. So we can put information inside these files. By default, it sets it up as W plus B. So what does that mean? It means that it's saying, I'm going to write binary information to this file. So we're going to do an example where we're going to go ahead and write the information to the file as binary, go back to the beginning of the file, and then read all the information that's in there. So we're going to use that with syntax again because we want to clean up at the end. I don't want to have to worry about it. We're going to push a binary, some binary data in, so just a string, but we're telling it it's binary. And then we're going to go back to the beginning, seek 0, the first position in our file, and then read out the information using temp.read, which will read the whole file there. So we see that we get Python is amazing, which is the expected result. Continuing on, if we know that we're going to be working with text data and we don't want to have to do that, convert everything to binary, we can go ahead and say, I don't want to open up as W plus B. I want to open it up as W or W plus T or whatever else other write modes that are available. So we can do, once again, that with tempfile.temporary files mode. And this time we're doing W plus T. So we now have a text writer. And we assign it the variable writer. We do writer.writeLine. So we now have that ability where you pass in a list of stuff and it writes it to the disk. Notice that for each new line, we have to put a \n because that's the new line character. So we're going to do the same thing we did before, except pass in straight up text. Go back to the beginning, and then we're just going to iterate through our writer and print out each line. And we're going to get our shopping list as expected. Now, sometimes you need to create, so notice before we didn't have any say over how our temporary files were named, but there's times where we need certain extensions for stuff, or and we need these files to be named a certain way. So we can go ahead and we can go ahead and do what's called a name temporary file. Now, this information isn't as secure as the other ones because we're giving it an explicit pattern to follow, and if somebody figures out what the various file extensions mean, it could open up your system for for attacks potentially, but really you're still minimizing the risk because the file names are still going to be random compared to just calling something secure.txt or something like that. So we can go ahead, we can see that we created our name temporary file and we didn't explicitly pass in any information, but we can get the name and then we can check if it exists, and we can see explicitly that outside that with statement, it does erase up even with this type of file. But let's say we need to have our suffix to be .text files and we want to put it a prefix on it so we can identify it with some operation. So we're going to say before that random file generation that we see up here, like this temp ke6 whatever, we want to put in front of it advanced underscore python underscore, and then we want it to be the extension .text. So if we go ahead and use that name temporary file, we get the same temporary file wrapper, and by default it's opening up in that binary read mode. But we can see that we are able to control the um, the extension type and the prefix in front of it. So we still get our temporary file name and temporary file, but now we were able to put a little more structure around it. Now we can do the same thing like we did before with files, but we can do it with temporary directories. So systems store information in what's called a temp folder, and each operating system, regardless if it's Windows or Mac or Linux, has one defined, and they're either set through environmental variables or on the system level itself. So on Windows, it's going to go, we can take a look at the system that I'm on, and we can see that my directory is my user, the username, and then the standard temporary directory for a user on Windows. And we can also get some other information like the temp prefix that's set by your system and stuff like that. But it's also important to know that there are temporary file settings within ArcMap and ArcPy itself, ArcGIS Pro, I'm sorry, not ArcMap. And these come out of the arcpy.env module. So, and it's env.scratch folder and env.scratch.gdb. And these are the two workspaces that you should be setting your intermediate data to write to, because when you want to go ahead and write information to ArcGIS server, let's say, so you're making a web-based service, you don't want to use the tempfile.getTemp directory. You might be tempted to do that. You should use env.scratch folder. Because temp files can change, Arch servers tend not to have full control of where they can read and write, and you might be trying to write to information that the user that the ArcGIS server is might not actually be able to write there. So you could, or might not be able to retrieve the results. So you can end up getting errors. So here you would always want to put information into the env.scratch folder and to the env.scratch.gdb. According to the help, it also says that within the ArcGIS realm, the ArcPy realm, it says it guarantees that the scratch folder and the scratch GDB will always exist. And that's a really important piece of information. So we can go ahead and build temporary directories and the subfolders, and this information we can, with this information, it'll all get cleaned up like we did before with the files, but it'll clean up everything. It'll clean up the folder plus all the files within it. So if you think of all the stuff you do, maybe you're downloading large amounts of files, unzipping it, doing some pre-processing and building out a new product. Well, you don't need all that other information that you got down, all these zip files that you unzipped and you smushed together some information, passed it into a bunch of tools, all that intermediate data. You don't need that. So you can go ahead and you can use this temporary directories to delete it. And just like the names files that we had before, we can do the name temporary, we can use this temporary directory and pass in our suffix and a prefix to get something that sort of lines up with what we expect for our naming conventions for this app. So what we're going to do is I'm going to go ahead and I'm going to use that with statement again, because I wanted to do, when my logic's done, I wanted to auto erase everything. And then I can go through and I'm going to create a file within there, just called test.txt, write some stuff, and then have it persist. And then I'm going to show that it exists in the current with context and within the context of where I am now in this context manager. But as soon as I exit it, we're going to see that it's been cleaned up. So let's go ahead and run that code. And so we created a file, our folder. Then we wrote a file within there, wrote some information to it, checked if it existed. It finished up and jumped out of this context with the with statement, and we went and checked it again, and we can see that it doesn't exist. So it cleaned everything up for us. Now imagine how powerful that is. If you have to maybe, like I said before, download data and you don't, after it's downloaded, you don't need it anymore. This is a perfect workflow to use because it always cleans up your system for you, and you won't have all these extra files lying around, and it keeps your hard drive space use minimized. So let's go back and um, look at the code that we did before. So we're talking about using unique names and temp files and all this stuff, and it generates these unique names. And how can we sort of enforce this with um, arcpy itself? Is there something in there to help us? And the concept of creating unique feature classes and tables is really important. So this was our original center code, and notice we had to go ahead and we manually had to pass in this index using the enumeration on the search cursor. But we can make an enhancement of that and leverage the arcpy.create unique names. And this is going to allow us to it ensures that whatever workspace you're working in, whether it's a folder or a file geodatabase, the information comes back and that file will be able to be written to that area. And and then we can use temp files to generate the folder to handle our intermediate data. And we're going to leverage the Scratch GDB and Scratch folder and in-memory workspaces as well. So let's see how we can sort of modify our code, and then we can do a little more, and then realize that we're going to sort of clean everything up at the end. So what we're going to do here is we're going to take and do our standard imports that we had before, and we're going to pass in our search cursor here. We're going to do the same. We're going to do a standard for loop here, well, same enumeration, but instead of using that index value to pass it in, we're going to use arcpy to create index and pass in the full path to our road lines, and that'll give us a new name and guarantee it to be unique. We can then go ahead and do some more information and clip out the information. I added some additional steps here where we're going to calculate our geometries and everything, and we're going to go through and sort of append everything together and get a different result. So let's go ahead and look at that while that's running. Before we move on, it's going to take a minute or so to run. So we're going to go in from each row. We're then going to pass it in, and we're going to get some additional information on our roads from our districts that we clipped. We're going to calculate some information for the school district, and then append the row to the rows. And what we're going to do with this is we're going to for each district we're going to pass it in, and we're going to get some geometry statistics about this information as we go through. And we're going to use pandas on the next slide to help us out. So let's go take a look at that code while this runs. So we're going to take that result object that we developed before, and that result object is going to put it into what's like an in-memory Excel spreadsheet. And it's going to allow us to do column operations and also row-based operations. So we can do summaries on columns, we can look at the data as a whole, and then we can also do things that allow us to sort of view the data, and we're going to go more into this as we go along. Same with NumPy as well. We're going to take this information, we're going to get some value counts, and we're going to look at this information. But here's just a quick way where we can take our information, which is right now, which is just a bunch of rows, put it into that list, into the data frame, and we get something where we can actually start touching the data and making it develop meaningful patterns. We're then going to import matplotlib, which is a graphing library, and that's going to allow us to create some rich visualizations. And what we're going to pull from here is we're going to create a custom color map that we're going to pass in based off of one of the existing color map schemes. And we'll get into that more of that with visualization in 2 weeks. And we're going to space it out, and we're going to take our one school district and do a value count, and we're going to get the number of counts that for each unique school district, and we're going to plot it out in a bar bar chart with our unique color scheme. So let's go ahead and take a look at that. So here we can see that the number of roads that exist within each school district in Adams School District has the most compared to any other school district by quite a bit. And these are just physical counts. We're not doing much of anything. So, and that's pretty much it. So sort of merging everything together. I hope you enjoyed this lesson. It gave you some insight of how you can take analysis, and you don't just have to stay within the arcpy ecosystem. There's a lot of powerful tools to help manage your intermediate data as well. If you have any questions, please feel free to put them in the forums.